Look at all this stuff. I've got to stop with the hoarding and start with the selling, I think. But anyway, have a look at these wooden boxes. As you can see, there's 10 that seem to be the same size. This one's a bit bigger, it's longer, and we've got 3 very big ones up there. So today we'll just have a look at these 10. I think they're all the same, and see what's inside them. Now, yes, it was a bit clickbaity of me to not reveal the contents of this in the title of the video, but hey, I could use some more views, and maybe implying that there's more than one of these might even attract a few more subscribers. But I'm not forcing anyone to watch the video to find out, and I've only got to click and the description will reveal what's in it. So, and I said there was 10 of these that were the same. Turns out one of them was a slightly smaller box, and it had the contents of that one was similar to the larger one, the 11th one. So they'll be mystery boxes 2 and 3 that I'll do in another video. But there's 9 like this, so let's see what's in it. We'll put some blocks under it. It's a Motorola MEK6802D5 evaluation board for the 6802 processor, which is basically a 6800 that doesn't need the 6875 clock generator chip for the crystal. The crystal just connects directly to the chip, and it's also got 128 bytes of RAM inside of it. Otherwise, it's a 6800. I've seen other versions, photos of other versions of this thing that have a TO220 regulator. I don't know if that's any smaller, but underneath this thing, which is an add-on by the Box Hill College of TAFE. This was a trainer used in TAFE colleges here in Melbourne, which are tertiary and advanced education, so technical school, and they obviously got this board and stuck it inside this box with a power supply underneath it, and they obviously made this add-on here. Underneath that there's nothing, just a wire wrap prototyping area. Later versions of this thing seem to have a proper breadboard, you know, this sort of thing, but bigger, running down there. So what's in this? 6800. It's got an edge connector for connecting to the outside world, and you would put driver chips there if you wanted to use that. It's got 2 peripheral interface adapters. This one is general purpose. It goes to the wire wrap area, and looks like they're using it for this add-on, which by the way seems to be a serial interface. It's got numbers that look like baud rates there, and this cable here goes down underneath to where the power supply is. So we'll take this out later and see what's underneath it. But yeah, that's what that PIA is for, general purpose. This PIA is dedicated to the unit. It connects to the displays here and the keypad. I believe that is RAM. A few pages extracted from the one and only copy of the manual that seems to be floating around everywhere on the internet, but it's all from the same source. Yeah, so there's one with TO220 regulator, but it's still got the wire wrap. And that is U11, which is a 6810. What's a 6810? I've forgotten. No, it is RAM. And you can have extra user RAM here. Yeah, so that's RAM. Not sure how big it is, but you can stick in a K of extra RAM with these 2114 chips, so that's been installed. This is the monitor program for controlling all this. There's room for a user ROM as well. You can make it do more stuff by putting another ROM in there. There's a bunch of jumpers around the place for selecting the type of ROM chip, for setting up interrupt addresses for these PIA chips. A couple of 3.5mm sockets there, because this thing can talk to, there's this firmware in this ROM to talk to a cassette tape using the Kansas City standard. Haven't heard that for a long time since I stumbled across this. We won't be doing that. Now, of the 9 of these things I've got, 4 of them don't have the keypad. There's a few chips under there, I think they're to do with the cassette interface. So, let's plug it in and see what happens. Turn it on. Did you notice what happened? A dash appeared on that leftmost 7-segment display. To make it a bit more visible, I'll just stick this red acrylic above it. I think that improves the contrast, and we'll zoom into that area. You can do quite a few things with this keypad. Enter programs, set up breakpoints, examine and change memory, examine and change the registers too. So the monitor, I believe, the program in there lives at F1000, and you just go F and press M, and that should be the contents of it, and then go should give us the next location. So that's the monitor, I believe, which the listing for that's given in the manual. I'll put a link to the manual in the description below, and you can go backwards with the M key. Now, the manual doesn't actually say how to change memory. It just shows you this stuff, how to examine it, but not how to change it. So if I go to, I think now it's trying to enter it, so what do I have to do to get out of this? Reset up there. Now if I do M and step forward, this is just random stuff in the RAM, I believe. So if I go back to Nord, now I'm back there again. I don't know how to get out of what appears to be data entry. Okay, M, if I put 1122, it's not advancing, 11, next location 22, next location 33, next location 44, then reset, 0, 11, whoops, going backwards, 11, 22, 33, 44. So that's how you put stuff in memory. And if you register display, I think, again, I don't know how you get out of that mode, but probably escape. There's an escape key. Oh yeah, I think it might be escape there. So now it's showing, I've done register display, so we've got PC, that's like what's in the program counter register. Again, you just use G and M to go forward. There's the A register, B register, index register, stack pointer, and condition codes. And it just wraps around, and you can go backwards too. So you can actually change the registers there, I believe. Let's try changing A, 1, 2, and let's see if escape takes us out of that. It does, okay. So we go back into register display and go forward to A. It's got that 1, 2 in it. Good. Now, I don't know if I want to enter in, there's a couple of sample programs. Might be a pain in the arse to enter it, but that's what you had to do back in the day. I'm not sure if I'll bother with that, but we'll see. Let's take this out and see what's underneath it. Right, I've taken out 4 screws, and this should lift up now. And good old Ferguson transformer, same brand as that line tamer thing that I used in a few videos ago. And a basic power supply, looks like, those are 2 CO220s. Oh, that's probably plus and minus 15 volts for the RS232. It looks like 1, 2, 3, 4. So I guess ground and maybe raw supply going to this thing, just and then plus and minus 15 for the RS232 going there. So now there's no chips on this add-on board. another crystal down there, which must be for the baud rate generator. Yeah, I think they've probably hijacked the cassette interface circuitry. Yeah, there'd be a UART type thing in there, which they've hijacked and are now using it for the RS232. Well, no, not exactly. Looking at the block diagram, which I should have showed you before, we'll go over that now. There's the processor, crystal, power on circuitry, the monitor ROM and provision for a user ROM, the 6810 system RAM and two 2114 user RAM chips which are installed, user PIA going to the breadboard area, bus buffers to the edge connector. If you want to use them, you have to put those chips in there. And down here's the keypad and display coming off the second PIA, power supply regulator. But yeah, there is no UART for the cassette. It looks like they're doing it all by bit banging out of this PIA. Yet there is a UART for RS232, so there is provision for RS232, so I don't know what all that's up there for. Surely it couldn't be that hard. All that just to get a connector. All this stuff here goes underneath the keypad. There's room for the crystal there, but they put it on the bottom. And yeah, they've extended the baud rate selection up to this jumper strip. And yeah, the power supply is probably plus or minus 12 volts rather than 15 for the RS232. So yeah, maybe it still does do the cassette interface bizzo. Not that I'm going to try that. There's room for the crystal there on the top, but they put it on the bottom. And U33 is the ACIA 6850, I think. Asynchronous communications interface adapter. And level translators, these guys here, which are MC14539 and 14584. Yeah. Will I stick in a little program? Yeah, why not? Alright, I've entered this simple little program which displays HELP dash, except that I've moved one of the dashes to the front, so it's dash HELP dash. And so the instructions are: load 2 characters into the index register, store it to the area in memory which the display comes from, next 2 characters, then to store it in memory 2 bytes further along, and then again for the third one. Call this diddle routine, I don't know what that does, and then jump to the display routine. So I don't know what diddle does. I haven't tried running this yet. But so there it is. I'll put in 0 and M and just go through it. And I thought I'd made a mistake, because after I finished at 18191A, I'll get up to 1. There's the last instruction. 7E FOBB, and then I press the next location after 1A, and I got 1.6. Huh? It's actually 1B. If we go backwards, that's what 1.6 looks like. Anyway, so then it says press 0 and go to begin execution. Let's do that. 0, go. That didn't do much, did it? Maybe you have to be in the memory entry mode. 0, go. No, get out of memory entry mode. 0, go. Ah, there it was. Not much happening. That's pretty disappointing. Let's have a look at it. My program's still there. Nope, it's been clobberated. CE's become 7.3. The rest of it's the same. No, that's been changed too. 1H should have 7E F0BB, and the 0 should have CE in it. Okay, we're still in memory enter mode. Press 0, go. No, get out of entry mode. 0, go. No, I don't bloody know. I'll have a bit of a muck around and get back to you. Now, I don't know what was going on there, but I found that if I get out of memory mode, reset, press 0 and go, it works. -HELP dash. Cute. Hope you found that interesting. Give it a like please, and I'll catch you later.